Alright, let's get this thing going. Because people are already here, so I might as well say hi. So, just to check, can people hear what I'm saying? I've got my two monitors set up here, so anytime I'm looking that way, it means I'm looking at comments and stuff like that. So just to make sure, can people hear me? Good. I have so many different possible setups here at the moment because I've got a webcam and I've got my laptop's camera and I've got a headset plugged in. I'm not even sure which microphones um, are uh, are currently set up. So, but if people can hear me, that's probably okay. Um, all right. Let me just set up one thing. I just need to set up the moderation stuff. I've got some of the tutors in here at the moment, and some of the admins just making sure that things are okay. I can't do it right now, Tom, so I will make you a moderator sometime when I have a chance to actually do it, because I know it's a quite involved process. It's going to take longer than I have time for right now. So we'll just go for it and see how we go. So as long as everyone can hear me, I can get started. So what we're seeing here on my screen, so I guess the only thing to be careful of is if I go off the bottom of the screen there and I'm trying to do stuff behind my face, people can let me know. I've got here, I've just gone into Google. Actually, let me just go back. I've basically gone into Google here and typed in Minesweeper, because this is what I'm going to talk about today. I'm going to talk a little bit about Minesweeper, so I thought I would show you a little bit in case anyone hasn't ever played the game. I'll just start it on easy because it's easier. If I click anywhere here, I get told how many mines there are adjacent to each of these squares. So each of these squares has one mine near them, and so this one I know for sure has one mine here, so I can right click there and I get the flag. Then I can clean out these other ones, because the ones, if they have one there, so this one says in this set of 9 there's only one mine, and they already know that one's there, so we can click there and that's safe. This one also, this is some of the strategy of Minesweeper. And I can mark where I think mines are in areas where there's a 1 and that. And then as you get more into playing Minesweeper, you'll learn more of the strategy and stuff. You don't have to know that much about how to play Minesweeper to do the assignment, but it is a little bit of fun if you do. And so you get a hang of it. Oh, I've got an issue here. Okay, so this one says there's 2 in this set of 9, so these 2 have to be. This one says 3, so that one has to be. That one says 2, so that one's open. There you go. A little bit of the strategy. You can play it as much as you want, fiddle around with it. I just wanted to show that for the fun of it. That's not true. My high score is way faster than that. Anyway, we're not going to go into that. I said in lectures that oh, thanks, Tom. You can mark where the flags are. I was saying in lectures there's actually a computer that has the original Minesweeper with Windows 3.1 on it in the sort of museum area that CSE has set up. So it's pretty cool. Okay, so we don't really need to look at that too much. I've got a plan for what we're going to talk about in the live stream today. These are my notes. You don't really have to know everything that's in the notes. I'm going to talk about everything that's in the notes, but it just happens to be on the same monitor I'm going to show you stuff on, so, you know, I don't mind if you see my notes. So, we're going to start off by going through Minesweeper itself and the assignment. So we're going to look at the assignment spec. We're going to talk about the structure of it, some of the things that you need to know to be able to get started, some of the things you need to know to be able to understand how the assignment's actually going to run as a program once you've built it, and also our ideas on how you should do it step by step, you know. So we're talking about, you can see in the assignment, so we've got a staged process of like which stages do what. We're going to talk a little bit about some of the commands and the reference implementation. We're going to talk about testing and marking. I have some slides for that as well. And then if people have questions, obviously the benefit of the live stream is we have questions, so people can ask more things. Every time I'm looking over there, as I'm looking at the chat. So just to see who's here, I mean, we've got 26 people in here at the moment, so ooh, it's going up. Lots of likes. Lots of likes and subscribes. I'm going to monetize this channel. I'm not going to monetize this channel. Say hi if you're there. If you're there, just say hi in chat. I will say hi also. I don't know exactly what the delay is, but I think the delay is sometime around like 10-15 seconds. So I'm going to say some things, and then you're going to get them in a few seconds, and then say things back. All right. Yep. There's a whole bunch of people saying hi now. Hello, everybody. So let's start with the first things I wanted to go through. There's heaps of people here. Oh wow, our old subject admin is here, Andrew. Heaps of people. Okay. So we're gonna start by looking through the spec itself. So I've got the spec open here. I'm not sure if that's big enough on your screens to see. I mean, if it's not big enough on your screens to see on the live stream, because the live stream might not have like full resolution, don't worry too much, because you can always just look at this spec on your own computer if you need to. But what I want to talk about a little bit is just the overall structure of what this assignment is going to be. Should zoom in? I should zoom in, so people ask me to zoom in. Okay. Because we can still see, like I haven't even cut off any of the width of the spec there if I zoom in like this. Hello everybody. Got lots of people saying hello. Looks like more people are turning up as well. Okay. A little bit of background on it. That link there takes you to the Google search game that I was just playing of Minesweeper a second ago. So, what was I going to say first? Minesweeper is a game that is played on a two-dimensional grid of squares. So it being on a two-dimensional grid of squares makes it pretty easy for us to immediately think of the ideas I've been talking about in lectures about using two-dimensional arrays. So if it's a two-dimensional grid of squares that has mines on it, we can use a two-dimensional array to represent it. We've made this at least a little bit easy for you to get started on by by giving you some starter code that has the ability to at least print out that array and stuff. Just checking. Apparently there's a bit of background noise and background static. I'm gonna turn my volume down a little, and I'm not sure if that changes things. Am I still loud enough to hear? I'm just trying to reduce the amount of buzz there is in the background, because I'm pretty sure that my computer's fans are just sort of going nuts at the moment because it's having to do a whole lot of streaming stuff and things like that. New volume's okay? Alright, good. We'll keep going then. Yeah, so when you first get given this assignment, one of the first things you probably want to do with this is look to what you need to do. And in order to figure out what you need to do, you need to understand what the structure of the assignment is. So the first thing that we have here in the spec is, okay, this is what the Minefield is. It is a two-dimensional array, and that array is just containing integers. So here in the array, each of these elements of the array here is showing you which row and which column they're in. So if we're going to be looping through the array via the rows and the columns, then we are going to use the first number of these is going to be which row they're in, and the second number is going to be which column they're in. Now, this can get a little bit confusing when we start out with these things, because if we're thinking about coordinate geometry in maths is always big cross with a 0 in the middle. X's are going up to the left, and up to the right and down to the left, and the Y's especially are going up. They're increasing in number as they go upwards, decreasing in number as they go downwards. But as I was saying in lectures, we're using this row and column structure for our arrays because it makes it much easier for us to loop through them. So we can draw one row and then we loop to the next row and draw it and stuff like that. So our coordinate system, you need to just start thinking about it in a slightly different way than you would in a mathematical coordinate geometry sense. But what we're going to get is the core data that we're using for this assignment is going to be the minefield, and the minefield is going to be of a particular size. Oh wait, that's the coordinates. I don't think we've got it declared here. Oh, actually, we can look at it in a second. I'll just grab the code in a second. We'll look at it. But what we're going to be doing is we're going to be accessing this element, the elements in this minefield, and making changes to them. So either we're going to be flipping them from have we seen them before to have we tried to reveal them, or especially in our debug view of this, we know where the mines are. So the standard output that we get usually when we're working with this, until you get to later stages of the assignment, you actually get the player's view, is this kind of back-end view, us thinking about ourselves as if we're like the referee in the game, and we're just watching where the mines are and telling the player whether things are working or not. So lots of little things like that we're going to be doing. But the good thing to remember is structure of the minefield looks a bit like this. Rows count downwards, columns count towards the right. And then each of the coordinates can be used to access a single square on the minefield. And I think that's the terminology we're going to be using for everything, is the whole minefield is a two-dimensional array, and each element of that two-dimensional array we're calling squares. And then we're talking about whether they're revealed or not revealed, and we have some hash defines in here that we're just using these as integers because these are the things that are going to be contained in the minefield, but they're going to be called visible safe, hidden mine. Those are three possible things that each square of the minefield can be. So visible safe is if the player has looked at that square and there isn't a mine there. Hidden safe is if the player has not looked at that square yet and there's not a mine there. And then hidden mine is if the player hasn't looked there and there's a mine there. There isn't a hash define for visible mine, because if the player has looked somewhere where the mine is, then they've exploded and the game has ended at that point in time. Okay, just checking. Yeah, okay. Just making sure no one's asking any questions yet, but I mean, I think you're probably going to wait until I've gone further into this before we talk about questions. So, there's a bunch of stuff that we're going to be doing for revealing and things like that, but I'm not going to go too much into that detail there yet. But let's have a look at the starter code here. So I actually am in a position now where I've currently got I'm just going into VLab there. I had that open already. But I have nothing for the assignment yet so far. So I'm going to go from scratch and show you the starter code. I'm not really going to do any coding here because, I mean, it's your assignment, right? And I think, as you know already in the lectures, I've dropped a whole lot of hints about the techniques I've been showing you that match up with the assignment, because the assignment is literally testing whether you've learnt the things I told you. So, you know, every now and then I'm like, look at that, we are looping through a two-dimensional array. I wonder what that could be used for, right? So you can understand how you're going to put that stuff into practice as it goes along. But I'm not necessarily going to do any code here. So I'm going to make a directory for my assignment. Let me call it Minesweeper. And I'm just going to show you how you can get started on this. So if you haven't started the assignment yet, I mean, like, if you already have started the assignment, or you're like one of those people that's already finished the assignment, I've had a few people just go, I think I'm finished now and stuff, and it's like, okay, that was quick. But really, I think it's okay, it's totally okay if you haven't started the assignment yet, because that's what I'm trying to do now, is like just give people a hand on how to get started. So the first thing you want to do is figure out what code you're going to use to get started. And we've got some starter code for you, which is set up to give you the framework that you're going to work with. So here we have a command for starter code, and I'm just going to copy this, paste that in there. This is a command that just copies a file that we have um, in the in COMP1511's directories, and you can just copy it into your directories, and then now you can edit it and use it and stuff like that. So if I do an ls now, I've got minesweeper.c in there. Let's have a look at minesweeper.c. Just going to tab complete that because it's the only file in there. Okay, so here is Minesweeper and things that you're going to want to edit. Make sure you put your name and your student number in here and the date that you're working on it. You don't have to worry about changing the version information. If you really want to, you can track your own versions in here and just go, okay, this is the version I got to when I started working on it, and then go up numbers, but not super important in this particular program for you to track versions. We're going to get to that later. Well, not us necessarily in 1511, but tracking versions and things like that is something that will be important later on in your potential computing career. Okay, so we've got a bunch of hash defines here. These are going to make some things a lot easier because we've got the visible safe, and hidden mine, all that kind of stuff. We also have the size of the grid, so we have one size for the grid. In the lecture example, I had number of rows and number of columns. The Minesweeper grid in this assignment is always going to be a square, so the size is going to be the size of one of the edges of it. Nice thing to make it easier for you as you go through the stages, each of the possible commands that you can receive is here as a hash define. We'll talk about those commands in a second. So I haven't really spoken about how this runs yet. I'm still just talking about the code structure, how we get started. So we have the basics here. We have a couple of functions that already exist for us to use, and you can see that both of them take in the Minefield, which is a two-dimensional array with the size as the rows and columns. So there's initialize field and print debug Minefield. So these two functions are things that are going to be reasonably useful while you're doing things. Initialize field is something that is nearly kind of for us. We set that up so that when we create the Minefield, there is a function that makes sure the Minefield is set up in a specific way. And that specific way, I think, is that everything is hidden safe to begin with until we start putting mines into the Minefield. And if we look at the code, we'll probably see that. So initialize Minefield here. We look at the code. We've got an I loop there, and that ends here with the I++, and a J loop here, which ends there with the J++. And all it's going to do then, if it's looping through I less than size and J less than size, we're going to end up with the Minefield all being given hidden safe. So that's just how we start it. And if we want to look really, really closely, hidden safe is equal to the number 1. So that number is going to be a valid value to put into an integer array, a two-dimensional integer array. The other one is print debug Minefield, and instead of putting values in, this time we're going to be reading values out and just printing them out. So the code, even in this state here, will be able to at least print out the Minefield. If I look at this, I'm pretty sure I can just run this code as it is. It's going to ask some questions, but because there's no scanf in here, it's not even going to wait for my input. It's just going to print all these things and print debug Minefield. We can at least see what we're starting with. So let's see if that compiles off the bat. I think it will. Let's call it Minesweeper. Minesweeper. And I'll run Minesweeper. Okay, so this is how it's going to start. It's going to say, welcome to Minesweeper. It's going to say how many mines, and it would have expected us to type a number in there, but as you can see, none of that code is implemented yet. So that's the kind of stuff that you're going to have to work on. So you're going to have to give it the number of mines, and then enter pairs of row-column coordinates, and then those mines would end up in here, and then once the game starts, it starts printing out the Minefield. So we can see for the moment our Minefield is just an empty Minefield. Everything's hidden from the user for the moment because the user has not interacted with the Minefield yet in any way. Cool. So that's the starting point, and I think this is where you want to be before you can even do this before you even start thinking about what you want to do. So at least at this point, you've got your code, and you've got your sort of scaffolding under which you're going to build the structure of the assignment, and you know that using our print debug statement, this is always going to come out in the right format, because we're going to be doing automated testing on the assignment to let you know whether things are working or not. And with those auto tests, you're going to want this output. You're not going to have to stuff around with that output to get it to match ours exactly. So we've got this output for you that matches ours. If you get to, was it stage 3, I think, and you want to do the player view output, that's when things get fiddly, and we ask you to format things in a nice way so the player can view it. It's always really weird doing the live streams because I'm actually at home today because I wasn't feeling that well, so I'm just actually in my house at the moment. You can see my bookshelves with all my toys behind me and stuff like that. The other thing is the diagrams might not be as good as normal because I don't have my stylus laptop here. That's my work laptop. So if I'm drawing diagrams today, they're just going to be with a mouse, and we'll hope they work out. Okay, so what else was I going to talk about? Okay, so we've got starter code. Auto test, we'll go through the spec and have a look at those. The reference implementation. Okay, so there's some other things we want to look at. It might actually be a good point here to have a look at the reference implementation. So to make it easier for you as you're trying to work on things, we do have a version of Minesweeper that is like a completed assignment. It actually is. It's what a lot of the spec was written from. I don't know if any of you have Liz as your tutor. Liz wrote this. She wrote a lot of the background for Minesweeper, and so this is her code here that that runs the way yours should, and you can always go back and forth and check to see if yours is running the way that hers is. Although we've had like one or two little bugs in it and stuff, but we're getting rid of them as fast as we can. So they're pretty easy to fix, because like sometimes like someone will look at it and like you king beans have gone like deep into the assignment early, like you've gotten a lot of help from you with those. But let me actually, before we go into the reference implementation, let's have a quick look at least through these stages and how we ought to approach the assignment. So there's 4 stages in the assignment, and each stage has a certain amount of code you need to write and a certain amount of things that you need to cover to make things work. Each stage leads into the next. I would at no point suggest you go to a different stage before you've completed the previous. So if you were to go straight to stage 3 and say, I'm going to do stage 3 before I do stages 1 and 2, stage 3 might not even work without stages 1 and 2, and will definitely be really hard to test without it. So it doesn't work very well to jump stages, but it works. The way that we're doing this is you start from stage 1 and then you go as far as you can. And I should point out that I'm going to talk about this in more detail, but you can pass this assignment without reaching stage 3 or 4. You can actually pass it, I think, just with a perfect implementation of stage 1, or a reasonably good implementation of stage 1 and some parts of stage 2, and you'll be fine. So a lot of the time I get this kind of idea that people will often come in and look at an assignment and say, I have to finish the whole thing, and that's not really the case. And so I don't want people to be sort of pushing themselves to levels of desperation to try to finish all 4 stages. It's actually not not entirely necessary. But in terms of like the assessment and exactly what it's going to be, we're going to talk about that later, because I really want to just talk about what you need to do and how you need to do it first, because I think it's like, you know, marks are important and all, but like, you know, like we're in a first year course here. What we're trying to do is learn as much as we can to try to get a good solid grounding so we can continue on and learn more about other computing subjects as we go along. So the marks you get in your first year subjects are not quite as relevant compared to the amount of learning that you get and how happy you are in continuing. So anyway, stages. we try to do the stages in order because each stage is going to follow on from the stages after it. So each of these stages has roughly 2 tasks. I think it's actually exactly 2 tasks, but I have to go through because I don't remember the exact split between all the stages as it is. So stage 1, the first thing that we have is the setup of the minefield. So when you're playing the game, you don't realize that every time you restart the game, the mines are going to move around and just be somewhere else. In stage 1, we're simulating the idea that there is something putting the mines in certain places. So we have a prompt that says how many mines, and then the user can actually type in how many mines are going to be in the minefield, and then the program is going to read in how many mines, that number of pairs of mines, and put them in. And so that way what we're going to get is the minefield will be populated by standard input. So we're going to be putting just a whole bunch of integers into standard input, and that's going to put the mines in the minefield. We can probably actually have a look at that now. So if I do 1511 Minesweeper, this is going to run our reference implementation to Minesweeper. Thanks, Tom. Very nice. I didn't actually look over to the comments for a while, but I was going to talk about marks spelt with a C, because sometimes earning marks spelt with a C is more interesting than marks with a K. I see my face is in the way. Let me move this over a bit, and that's still a bit too far. Alright, there. That's good. Okay. So, how many mines? Let's just put 4 mines in there for the moment. And now we have pairs of integers. So these are going to be row column pairs. So I'm going to put my first mine in the second row, 4 along. So remember, I'm saying second and 4 when I'm typing the numbers 1 and 3 because all of our arrays are starting from address 0. So that's 1 mine. And then I could type in another mine. Let's put this one in the bottom corner, so 7, 7. And then I'll put another one somewhere near the middle, so 4. Ooh, I pressed enter by accident there. This is the interesting thing you'll notice, and like with scanf and stuff, is that it will just grab the numbers you type in. So I'm pretty sure this is still going to work. If I do 4, 5, like this, and then how many mines do I have? I have a 4th mine, so it's another pair of coordinates. I'm going to put this next one at I don't know, 6, 3. I'm just picking at random things. So note that even with the different me pressing enter in between, scanf is still probably going to be okay with this. I'm pretty sure that in our testing we're probably not going to be giving you this random extra line stuff, but either way scanf's probably going to be okay with it. So let's have a look at where they are. 1, 3. 1 is down 1 row, 3 is across 3, so 1, 2, 3. That's one of our mines. So if we look at our hash defines for the number 2, hidden mine. Cool. So we know that that's working. That's what we want to see. The hidden mine says this is something that the user doesn't know about. Well, I mean, the user just kind of told us where they were, but the player doesn't know about. And then we had 7, 7. That was in the bottom corner. Then 4, 5 should be 4 down. So 0, 1, 2, 3, 4, and then 0, 1, 2, 3, 0, 1, 2, 3, 4, 5. Okay, so 4, 5's there. 6, 3 was down 6 and across 3. So you can see how I've entered those pairs of numbers, and then I've edited my minefield, and my minefield now has those mines in those locations. So that's the first thing that we need to do. And the kind of things that we're going to need to do to be able to do this is, and then we go into that kind of, we're not talking about that problem-solving mindset. It's like, okay, let's break this down into its parts. We're going to need to ask how many mines there are, so we need to read in one number first. Given what that number is, that decides how many times we're going to read pairs of numbers in. I don't know if we have any code structures that we've learnt that will allow us to do exactly the same code an exact number of times. Maybe we do. We'll see. Yeah, we do. Anyway, so we're going to go through and we're going to take all of that information in. Using each of these pieces of information, we're going to be accessing a certain square in this minefield and then changing that to a hidden mine. I'm going to leave that to you to work out, because that's the kind of thing that, I mean, I could have done an example very much like this in the lectures if I want to, but instead I did the tourist example, which was moving around in a grid that was very similar to this grid here and changing values as we went around. You might be able to glean a lot of useful information out of that example that I did. I mean, I intentionally did it not to be exactly the same as the assignment, but you'll probably be able to use a lot of that stuff anyway. Even if you don't use the code itself, you'll be able to use a lot of the logic from it. I should point out something, we talk about issues with plagiarism, and a lot of the issues that we get early on with plagiarism is sort of the understanding of what you can and can't do when we're trying to assess you as an individual. So the assignment's an individual assessment, which means that what we're trying to do is figure out what you know yourself, not necessarily what someone else who you know knows, and how much you've spoken to them about how to do the assignment. So we want a lot of the problem solving to be your own. We're happy for you to do code reviews and stuff on each other's labs and stuff, but I think you don't really want to look at other people's assignment code. You definitely don't want to pass assignment code back and forth, because if you do that kind of thing, all you're going to end up doing is losing the learning that you're getting here. And if you give up the learning in order to get higher marks at this point, it's nearly like, yeah, you'll get higher marks in 1511, but you're sort of just going to guarantee that you're going to have more trouble later on because you didn't learn this stuff at a deep enough level. So I'm okay with you using any code and any logic and stuff that we've taught you in the course. So if the code that you implement for something like this looks remarkably similar to stuff that I've done in lectures, I have no problem with that at all, unless I made mistakes in lectures. Although we've got smart cookies in the lectures who seem to be picking out whenever I have made mistakes in the code, or whether I've inserted mistakes in the code just to see whether you can catch them or not. So I do like the fact that people are picking out that kind of thing. But yeah, you can use the lecture code. It's never going to be exactly what you need, but a lot of it's going to be what you need to learn about to be able to do stuff like this. Okay, so I've only got through the first stage so far, but the first stage is putting the mines in, and you can see how this tests a lot of what we've told you about reading input and stuff like that, and also accessing arrays. So we haven't had to do that much yet. Right, all we needed to do here is the input-output from the first couple of weeks and accessing arrays. So we did kind of need to know what a 2D array is, but even that is like, just accessing it and changing the values is stuff that we've definitely covered. Okay, the next thing we do is count the number of mines that are in a row or a column. There are two things going on here. So one thing is, this is our first command in the idea of the game that loops. So we're in a game that takes a command from us and then does some kind of processing. So in Minesweeper that we're doing here, what we're having is that we've got our minefield, and then we have a command. When we have a command, it always has one integer, and let me just go back here. One integer that matches one of these. And whichever one of these it matches, that determines what thing it's supposed to do. And so depending on which number you read in, you will then need to read in some more information from the command. Actually, some of these commands don't even read in any other information, but a lot of them read in some amount of other integers, and you have to use those integers to decide what that command's going to do. It's actually really similar to this beginning bit, which is not even in here, right? That isn't the code. But this beginning bit here that said, okay, I'm going to read in how many mines, and depending on what number I read in that first number, that changed what I was going to do here. So in this one, simple example, it just changed how many pairs of numbers I was going to read in for where I was going to put the mines. As you go deeper into the assignment, it gets more complex what goes on. So the first ones are detecting in a row or a column how many mines are in the row or column. So what this is going to do is going to take, let's go back to the diagram, like this one. Let's say that there was a mine here. If I said, I'll give you the command for detect column, and I give you a 3, you will be able to look at all the elements in the column 3 and say to me, there are no mines in column 3. And so this would, stage 1, detect, it would then print out exactly how many mines it found in that row or column. And then after that, it will print out the current state of the minefield. The way that we're having it is that every time you type in a command, it will then print out the state of the minefield. This may change depending on how you're printing out the minefield, but every command will always just print out a minefield afterwards. So it's nearly like this is considered a turn-based game, where every time you type in some commands to do something, then after that the minefield displays what the state of the game is afterwards, and then you can type in another command after that. So let's have a quick look at this. So if I, actually, before I go there, let's look at the format. So detect row is command 1 followed by a row number. Detect column is command 2 followed by a column number. So we've got some examples here. So 1-1, that was checking the second row, row, not column, and 2-1 was checking the second column. So if we go back to our example, which is still running in the background here, I could check if there are any mines in the top row. So I say 1 for detect row, and I say 0 for the top row, and it'll tell me how many mines there are. There are 0 mines in the top row. As we can see here, 0 mines in the top row. Let's check a column. So I'm going to do the command for 2, and let's go 0, 1, 2, 3. Let's go this column here, because we know this has got 2 mines in it, so I'm hoping that this thing is going to tell me that there are 2 mines in there. So 2 was detect column, and 3 was the column that I'm looking at. There are 2 mines in column 3. Cool, right? Okay, so this thing is giving us information about whether there are mines in rows or columns. This isn't actually part of normal Minesweeper. This is just stuff that we threw in because we wanted to get you working in particular ways. Because it's not just, we're not just making a game, right? As much as I love just making games, we are trying to teach you about specific things to work with, arrays and looping and stuff like that. So, I mean, I'm nearly giving away how to do it. There are arrays and there's looping, and you can kind of already tell that if you're going to, say, isolate a row or a column and find out how many things are in it, you probably need to look at all of the squares in that row or column and then count how many mines you see along the way. Pretty certain that there are more than one lab exercises that will replicate this kind of behavior, where we're looping through a single dimensional array and then getting some information from it. I know I definitely did that in one of our lecture exercises, and I know I've put it in at least one lab question as well. So there's going to be a lot of structure that you can use from what we've taught you and what you've had to work on before, and then you reapply it in a different way to this. Because I don't think we've gone through a single dimension of a two-dimensional array, so you need to figure out how you're going to work with those dimensions. But otherwise, the idea of looping through all of the elements in an array should be reasonably familiar. You should have seen it before. Okay, so there are some more things happening here. I'm not going to go through huge detail of all of the rest of the stages in this, because there's other things that I do want to talk about. But I will at least skim through this and talk about them. So, stage 2 has the same kind of thing as the detect row and detect column, but this time it's detect square. So detect square is quite interesting because what it's doing is it's picking a square somewhere in the minefield, and it's saying, can you count how many mines are in this square? So, I mean, we nearly called this one the metal detector, because it's kind of like, okay, how many mines are in this area? Can we tell if there are mines nearby? And before, when we were doing rows or columns, we were just scanning the whole row or the whole column, but the square is quite different because we're actually just picking out an area. And it's not a fixed area either. If you look here, the detect square command, that's a 3, will be number 3, followed by the row and column of the center of the square. So we're going to tell you where the middle of the square is, and then we're also going to ask you, where is it, here? We're going to ask you to draw a square of a certain size. So that size is the side length of the square. So in this example here, if we said 3, 3, 3, 3, 3 is the command. So it's hilariously confusing because they're all the same number, but you need to be able to piece these things apart. So 3 is the command. The command says we're going to count the number of mines in a square. Sorry, detect the number of mines in a square. 3, 3 is the next two numbers. Those are the center of the square. So the center of the square is coordinates 3, 3. 3 is the size of the sides of the square. So we're building a square around 3, 3 that is exactly 3 wide and 3 tall. So that way we get this particular square. If we'd put a 5 on the end here, this thing would be 1 bigger in all of its dimensions. And I'm pretty sure, if I remember correctly, we're only going to be giving you an odd number here, because an even number is a bit awkward because we can't define where the center is. So it's going to be an odd number here for this square, but it's not fixed at 3. It could be bigger or smaller than 3. And so this is like a harder version of the rows and columns thing, right? You need to detect how many mines there are in a specified area, and the area has been specified with a center and a size. So there's a little bit more work going on there to try to figure out how many mines are in it. The next thing is where we get into the idea of what would happen when a human actually plays this game. So when a human actually plays this game, they're going to be clicking on squares, which is going to reveal them. And revealing has the possibility of causing the end of the game. If the player was to click on a hidden mine, that would end the game. Or if they click on empty space, they would reveal that square and possibly reveal other things around it. So when we're doing reveal square, we're revealing a 3x3 section of the grid. So that's that same kind of 9. We're attempting to reveal this square of 9 squares, in a sense. And so there's a few rules that this thing's going to follow. If they try to reveal a mine, then we have game over. So the command is a 4, and then a row and a column. So it's just going to be 3 numbers. Wait, where are they? Oh yeah, this is the example here. Yeah, so that's got the mine there, and you put in 3 numbers there. So what we're going to get is, if you are somewhere where there are no mines adjacent to you, so that we're getting the idea of what is next to what. So any square that is next to a square we click on is counted as adjacent, but the diagonals are also counted as adjacent. So every square will have 8 possibly adjacent squares to it. If it's on an edge, it'll have less. If it's in a corner, it'll have even less. But usually it's got 8 things adjacent to it. So it's the entire ring of squares around it. So if there are no mines adjacent to the square we click on, it will reveal all 9. If there is a mine adjacent to the square we click on, so these 2 yellow spots here are places where we could have clicked, then we will only reveal the square itself. And then the idea is, you're too close to a mine, it's too dangerous to try to reveal them all, so there's a mine somewhere there, and you can only reveal that one square. We can have a look at this. So that was command 4, I think it was. Let me make sure I got that right. I'm pretty sure it's command 4. Yeah. So we've got a few places here that we could potentially click on something. So if we aim to click on this one here, so that's like 0, 1, 2, 3, 4, 4-1. So I try to click on 4-1. What that's probably going to do there is attempt to reveal that square and the squares around it. So I've revealed that square and the squares around it, and it was able to tell me that there were no mines anywhere right next to that particular square. But if I was to say try to reveal this square here, which is 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, so 3, 5 I think that was, yeah. So the command is 4, and the coordinates I'm trying to reveal is 3, 5. It will reveal one of them, that's the one I clicked on, but it won't be able to reveal the whole area around it because it's too dangerous, because it detected there was a mine nearby. So when we're working with this, now we're getting into the idea of when we try to do something, we need to find out where we are in the minefield. Then we need to look at our surroundings, and then depending on what we see in our surroundings, that's going to change what code we run afterwards. So you can see how what we're doing is trying to get you into the idea of, like, programs don't just blindly go down a path of things. They're always going to decide what they do based on different situations. So we've set up this kind of situation, which is reasonably similar to what happens in Minesweeper. In real Minesweeper, this probably would have revealed a bit more than what it did. But in real Minesweeper, if you click on a square that is right next to a mine, it's not going to reveal the area around the mine. It's going to say, no, you can't get any closer to this without it being dangerous, so that's all I'm going to reveal. So it's not exactly Minesweeper, but it's getting us towards the functionality that the actual Minesweeper game does. So if you got to this point, you could actually start, in a sense, playing the game. It's not as interesting to play the game where you can see where the mines are, but you can at least start to reveal things in a similar way to the game itself. I think that was... yeah, that was stage 2. And then stage 3 is where we have some more stuff going on here. So one of the simple things in stage 3 is count how many times people use hints. So the detect row, detect column, and detect square, they're all hints. So they're all things that don't actually exist in the normal Minesweeper game, but they could be ways that you could change the game to make it easier for people to play. So they'd be able to tell how many things are in a row or a column or a small area. So we have this thing that says, if the user has used 3 hints and they try to use another hint, they should say, help has already been used. So we can actually do that now, because in this game here, I have used help twice. So let's do the detect square, centered on, I don't know, this area here. So that's 0, 1, 2, 3, 4, 5, 5, I think it is. 5, 5 of size 3, so there's a group of 9 there that I want to investigate. And there's one mine in that square, so I had a square centered on 5, 5 of size 3, which I think is that set of 9 there, and there's one mine there. Now if I say, oh, actually I really want to check that column there. So I check the column 0, 1, 2, 3, 4. Oops. 4. It says help's already used. I'm not going to give you any more information. So this is just a way of saying we're not going to just let you just check all the possible squares here so you know exactly where the mines are. You're only going to get a certain number of hints before they dry up. So each of these things, when you look at them in isolation, none of them are kind of earth-shatteringly difficult. So what we've done for you, in a sense, here with this assignment is, if we'd said, give us a nearly complete implementation of Minesweeper, and that's it, so the entire assignment spec was just one line, I would like a nearly perfectly functioning game of Minesweeper, here are some auto tests, good luck. That probably wouldn't have helped you that much. So what we've done for you is like this sort of first stage in breaking the problem down into parts, and then allowing ourselves to sort of start with the easier parts, the fundamental parts of it, and then build these up as we go. So the restricting hints bit is something where we kind of want the hints to already been made before we start working on this. So this is something that you you can do reasonably easily. It feels like, you know, maybe a lab exercise worth of work. Um, but it's all pieced together into this larger context of what this assignment is. Alright, so that's that one. Now we get to, I think, one of the coolest ones is the formatting printing, because this is where we can turn this thing into a game that can be played. Really, really simple, single integer commands, the two of these. So the 5 or the 6. The 5 or the 6 are just going to switch between two modes. Debug mode is what we've been seeing already. Debug mode is this one. We can see everything that's in the Minefield. We can see what things the player has revealed and what they haven't revealed. The cool thing about the debug view, if we just go back here, the debug view is just that. But the cool thing about the gameplay view is turning on gameplay mode shows you only what the human would see, and then it looks a lot more like that Minesweeper. Actually, let me just go back to Minesweeper. So, note obviously that me as the player right now, I can't see where the mines are, so I can't see what's hidden mine in here. But if I click on it, ooh, that was a nice start. Now I know all of the areas that I've revealed. Obviously, this level of like revealing outwards like this is not necessarily what we need you to do for the assignment, because it's a little bit beyond what we've taught you so far. But I can see that some cells, some squares are hidden, some squares are revealed. But there's all these numbers here as well. And we haven't done anything with these numbers yet in this assignment. But these numbers say, this is my count of how many mines there are adjacent to each square. Right, so I was saying that at the beginning. And if we know how many mines are adjacent to each square, we can go about trying to solve the puzzle that is Minesweeper. So the gameplay mode's actually going to turn into that. It's going to say if a square is revealed and there's a mine nearby, it's going to say how many mines are in its eight possible mines around it. Otherwise, the non-revealed squares, the anything that we haven't clicked on or we haven't been able to explore, is going to be covered up. So now we're not going to know where the mines are, we're going to see what the player sees. So if I just turn on gameplay mode there, now we get this nice kind of easier to view version of the game. So here we have the smiley face, and the smiley face says, I have not yet stepped on a mine, so the game is still going, I'm still happy. If you... Actually... Did we have a picture of the Minesweeper? Oh, I'm just going to look it up. The old images of Minesweeper, what the game actually looked like. Here's a... That'd be like a Windows XP version. It's got this little smiley face here, and the smiley face stays happy until you hit a mine, and then it goes frowny. So we're doing that a little bit in ours here, where there's a kind of a smiley face there. And what we can see here is we had the revealed squares, so we had this set of 9 revealed and this one revealed, but now we've got these little numbers turning up, and these little numbers say that somewhere adjacent to each of these there is one mine for each of these. So I don't know which square that's in for either of these, I just know that they're near a mine. So what I would then do maybe is, to play this game, I would be looking for exact ideas of where the mines are. Chen, yeah, definitely. We're going to, like, this will all be recorded when we're done, so you can always come back and view it later. Thank you for sticking around. Yeah. Sorry, I did it when I knew that there were no COMP1511 labs, but there are obviously going to be labs for other subjects and stuff like that. But thanks for coming by. Yeah, but this will all be recorded, so this was intended not just as a live stream, but also as a video for the course, because we've got, we've got some people here, but I want people to be able to also re-watch this stuff if they need to go back over it. Okay, so this is the gameplay view, and the gameplay view doesn't show you where the mines are, but gives you these clues. So now you need to piece together how you're going to deliver this output, which means you need to draw different things depending on whether a square has been revealed or not, and also different things depending on how many mines are adjacent to that particular square. Let's go back. No, that's my Facebook. We're not going there. Right. So yeah, the gameplay mode is kind of interesting because it gives you the ability to see what the player would see. So you could nearly, once you get to this stage, if you want to, you can get one person to put a bunch of mines in, and another person to come along and try to play the game in the gameplay mode, and you'd actually get a simplified version of Minesweeper. It doesn't do the full reveal of everything, but it does a simplified version of it. Then, stage 4 is an interesting one, where we have done a version of the reveal. So here, when I clicked here, it revealed all the squares that were not adjacent to mines, that were connected to the square that I was clicking on. In order to do that, there's some code constructs and ideas and techniques that we'd have to get into that we haven't really done. So that's part of the Hall of Fame, which I'll talk about later, but we don't necessarily have to do that. But we do have one way of just, if we're clicking somewhere, to try to expand the board a bit more than we have here. So, oh wait, it's here on these. This is what we're calling Reveal Radial. So we had Reveal Square, which if there were no mines adjacent to where you clicked, it was going to reveal the 8 squares around in a square. But now we have Reveal Radial, which is going to do something quite interesting, where it does an 8-pointed star. So 8-pointed star has 8 directions, up, down, left, right, and then 4 diagonal directions. And what it's going to do is when we click on something, it's going to send arcs of exploration off in 8 different directions, looking for empty spaces which we can reveal. So if we want to think about this in terms of degrees, depending on which kind of maths you're doing, I think 0 degrees is to the right, yeah, and then it goes around. But if you wanted to, you could do 0 from the top. It doesn't matter. What we're saying is each of these is 45-degree increments. So there's up, diagonal, right, diagonal down, right, down, diagonal down, left. Am I doing that from my perspective? This is diagonal down right, isn't it? I'm doing it from the way I'm thinking. But anyway, and all the way around. So what we get is something that looks like this. So it's going to explore the adjacent, and then it's going to keep trying to explore outwards until either it reaches the end of the minefield, or it reveals a square that is adjacent to a mine. So if it reveals a square that's adjacent to a mine, it should say, I have to stop here, because if I go any further, I have a risk of hitting a mine, and I don't know whether it's there or not. So I don't know if it's in my reveal path or not. So this reveal is just going to open up a whole lot of space, potentially, and try to reveal as many squares as it can in any direction until either it gets near a mine or it goes right off to the end of the edge of the minefield. This is the hardest thing that we're going to ask you to do in this assignment, and you can kind of see how it combines everything that has happened before in the assignment. So each time this thing runs, it's going to extend, well, sorry, when this thing runs, it's going to extend 8 lines outwards from where it is in different directions, and for each of those, it's going to check for adjacent mines every time it steps further outwards. So you can already see, if we wanted to break this down, we're talking about moving through a 2-dimensional array in a specific direction. If you've done all of the lab exercises, we've definitely done moving through a 1-dimensional array in both directions. We've also looked at moving through 1-dimensional arrays, not necessarily going through all elements, but only going through some of the elements and stuff. So there's a lot of little bits of coding that we would need to piece together to get this thing to work. If we were to ask whether we're adjacent to a mine or not, strangely enough, we have potentially some code in count the number of mines in a square that might tell us whether we're adjacent to a mine or not. So there might be the capability, depending on how you've written your code, of reusing some of the functions that you may have written in the earlier stages to do things again in the later stages. And that's where we get into like sort of the elegance of programming is anything that is potentially reusable, we can definitely reuse it. And if we write our code the right way, we can reuse bits and pieces. Um, Anyone chasing HDs, that's where you got to be. So let me go back to my list of things I was going to talk about. Okay, we talked about how it runs, we showed some basic commands. I showed more than basic commands. And then we're going to talk about testing and marking and stuff like that. However, I've just been talking for an hour, and my voice, I think you can hear it, my voice is a little bit tired. So let's take a 5 minute break, or roughly 5 minutes. I'm just going to like have a little bit of water and stretch for a second, and then I'll come back, and then we will continue. I'll talk about our testing and our marking and our assessment and stuff like that, and then that should give you a sort of general overview of how you want to approach the assignment and what the kind of what the criteria are that we're looking for you to have the correct performance in the assignment and stuff like that. So we'll take a break now. We'll come back soon. We'll talk about marking and stuff, and I got some other stuff I want to talk about as well. Can you hear me now? Now I have unmuted the correct microphone instead of unmuting some random microphone that I'm not sure what I unmuted. Are we good now? I hope so. Well, I can see my little bars going up and down, so I'm assuming that I'm actually streaming audio this time. Yay, good. Okay, I'm back. Okay, so I've got some slides, but I think that... I'm going to shrink the slides because my little face camera there is going to be cutting off some of the slides. So, I've already spoken about this. We're talking about Minesweeper, although we haven't talked that much about submission. So submission is through a system called Give. I've got another slide about that anyway, so I'll talk about that in a second. So you know Give reasonably well. You've been using it for your lab exercises and your weekly tests. There's one little addition to this, but I'll talk about that in its own slide. We've talked about the sequence of commands. We haven't talked specifically about the ending of the sequence of commands, but I think at this point everyone has done their tute and lab for this week, so we have talked about what happens when we end the input stream. So which one are we? Oh no, I was in the right one. It's here. I think it's stage 1 or stage 2. Second half of stage 1, maybe. Second half of stage 1, yeah. So you can loop through reading commands, processing the commands, but at some point you're going to receive the end of input, which is the control D. And so everyone's had a bit of practice with that in the tutes and labs now. If you haven't, go back and check out some of the content that's in the tutorials and the labs, because there's some information there. Sometime this weekend, as usual, I'll be releasing the tutorial answers for that week as well, so you can go back and see what's in actual text what we meant when we were in the tutorials. So what we're going to be doing is just continually reading in those inputs, and then at some point we will stop receiving inputs, so there won't be any inputs left, and then the program can end there. What was I going to talk about? Yes. Oop, that's not it. It's the other set of slides. Okay, so the program's just going to keep running until it runs out of inputs, which means it does potentially have a loop that can go forever. But even so, that loop's going to be using user input all the time, so it's not just going to be spinning and doing the same thing forever, it's going to be waiting for user input. So I was talking about Give a second ago. So one of the nice things about the way that we've set up Give at the moment is it will be saving your code every time you put it in. It's not just saving your code, it's using a thing called Git. Git is a source control program, and that's a piece of software that keeps track of the changes that you've made in your code. And what it will allow you to do, if you want to, you can use the web address here, that's available in the spec as well. If you change the ZID here to your ZID, you will see all the times that you've submitted. So this is something that I teach people a lot, is that your data is not safe unless it's in 3 physical locations. So in this course there will never be any kind of, I accidentally deleted my code, can I have the marks for it? We're never going to give you marks for you deleting your code. We're going to give you marks for what code was tested and how well it worked. But the good thing about that is every time you submit, your marks will be saved in a completely different physical location to where you are working on it. So these is on a GitLab server, which is a separate server to your computer, obviously. So even if your computer will just, like, I don't know, get thrown out the window and smash onto the street below and things like that, whatever you submitted last will still be there. So submit early and submit often. There is never a problem with submitting. Your code doesn't even have to run when you submit. I mean, like, it's going to tell you that it doesn't run when you submit, but it doesn't matter. You can be like, okay, I was up to here, I was up to this point, and I haven't fixed all my problems. Doesn't matter, submit. And so The best is to see someone who's, say, worked on the assignment for, I don't know, 12 days or something like that, and then there's like 12 different submits, because they're like, okay, on this day I got up to this point, and this day I got up to this point, or even more. It doesn't cost us anything for you to submit this thing, 100 times. It's not a problem at all. And what that means is, if you did have a lot of submits along the way, um, and something goes disastrously wrong on your laptop or something, or on your computer or on the lab machine that you're working on, and you accidentally corrupt the file to the point where it doesn't run at all, and you can't get it working again, you can just go to this GitLab and go, I'm going to go back one step. I'm going to back one step to a point where I knew it was working, because I knew that I submitted at a certain time and it worked, and then I'm going to get it back again. So it's nice and it's good. That way we can track your progress and things. The other thing that's nice is that we can see what is on your GitLab. And so the nicest thing about that is, you can say on the forums, you can make a post on the forums and say, my assignment's not working. I've tried this and this. This is the stage I'm working on, and I'm not sure how to get this going. And so whoever answers you, one of the tutors, or maybe your own tutor if you're talking to them about it, they can just grab your code from there. So we don't really want you passing code around. We especially don't want you copy pasting code onto the forums, right? Because the whole thing about like having us not look at each other's code, if you put it on the forums, then suddenly everyone can see your code. We really don't want that to happen. But you can just say who you are, basically, and then we'll be able to find your code. So we can see the code that you've auto tested, and we can see the code that you've submitted. And so it's really easy for you to say, I've got a problem. I'm on the forums. This is what my problem is, and then we can actually just grab your code. You don't even need to send us the code, as long as you've submitted. You go, oh, I just submitted. Then can you help me with the problems in this section of the code, and we'll be able to do that. So it's a system that just makes it really easy for us to communicate about these things. Right, so testing. We've got a couple of ways of testing that things are going to work. So I'm going to talk a little bit about testing for while you're... Oh, Dean, who is one of our forum managers, is also saying that you can submit questions anonymously to the forums as well. So you can submit the questions without, if you don't want to give away who you are or anything like that, you say, I've got this problem. We can still access your code, even if you submit it anonymously. No one else is going to see, but we can still see and look up your code if we need to, and give you help with it. So yeah. So there's a few different ways we can test our code. So there's testing while we are working on the assignment, and then there's testing that we're going to do in your assignment to decide how many marks to give you, and what kind of feedback to give you about how well it's working. So a couple of ways to test. Simplest way, but possibly the slowest way to test, is to simply type in your own commands. So we were doing that a second ago here. It's actually still running. So what was that? Reveal radial was like a 7, and I can do that somewhere in the middle. Oh, I didn't get to reveal radial because I happened to put it right next to a mine. Let's try 3-3, just so you can see the reveal radial. It didn't do that much of a radial reveal anyway, but it just revealed a little bit. So these commands are going to keep going. I can't remember what I was saying there. Where are we? Yeah, and so this is one way of testing. Oh, do you have a question there? Ah, right. I think Dean can help you with that. Olvester? 1, 2, 3? Yeah, Dean will probably be able to help you. Anyway, we can test with typing our commands in. We can actually write a list of commands ourselves and have those commands get piped into the program as if they'd been typed in. So there's a few different ways here, and we also have auto tests as well. And you'll note that for each of the stages, they have a thing where you can auto test only one stage at a time, because there's really no point auto testing the entirety of Minesweeper when you've only done stage 1, so you can limit your auto test to a certain stage. The other thing that you can do is the reference implementation, which I've been using here. This is kind of the gold standard under which we will be comparing your code to. So depending on how yours runs and how this runs, we're going to be comparing them to see whether yours is working or not. And you can obviously compare it as well. So if you think something's weird about what yours is doing, you can always check against the reference implementation and see whether it works or not. So I ran this by, I'm going to Control D out of this, by using the command 1511 Minesweeper. Right, so that's one thing. But then there's what we're going to do when we're testing your code. So bear in mind that you can pass all of the auto tests for code, but there can still be some things missing. We're going to test you against what we expect your program should do based on the specification. The auto tests are never going to be 100% complete because there's just too many possibilities for inputs and outputs for us to test everything. So we're going to need to test more stuff maybe in the marking tests than we have in the auto tests. And occasionally there's actually going to be things in the auto tests that are intentionally missing. So we don't want you to just simply be programming based on whether or not you match the auto tests, because the auto tests are something to help you learn and something to help you verify your code, but in the real world they don't exist. I mean, they do to a certain extent, but most of the time in the real world you don't have this perfect thing that tells you exactly if you're right or wrong. You just write code and you hope. Well, you don't hope, you test it yourself, and you're very careful with it, right? And we're going to build up these skills as we go along. But what we want you to be doing eventually, because the auto tests, we are going to remove the auto tests eventually. In fact, in some of the later lab exercises, we're going to be giving you some lab questions which either have no auto tests or have a limited set of auto tests, and we're going to talk about what the difference is in trying to implement something where you don't have this kind of, I mean, they're kind of like training wheels, you know? Like when we're riding a bike for real, we don't have the training wheels on. But when we're learning at the beginning, we kind of need them so we don't fall over. So I want to talk about the theory of learning how to ride bicycles. Balanced bikes are much better than training wheels, but we're not going to talk about that just yet. Let's have Mark do a live stream on how to teach people to ride bicycles. Okay. So we're going to move on to the actual thing. So what you want to make sure is, yes, you want to make sure you're passing all the auto tests, but you also want to make sure that the code that you're writing matches the specification. Because I've said this before in class, you could technically write down all of the inputs on the auto test and all the outputs they're checking for, and just go, if input equals this, output equals this, and then you just have this input-output box that spits out exactly the right thing for the auto tests. And that thing's going to fail every single marking test that we have, because we're never going to test you at exactly the same thing. So the most important thing is that you're programming to what you need to program to, not just trying to tick off the auto tests and get them correct. Okay, the marks themselves. So I said before I was going to talk about exactly what our marking criteria is. So I've got some notes on the marking criteria in my slides here, but there's also the assessment criteria here. And we've got some details about what it means to be working with other people and things, and what we want you to be working with in the assignment. The way I like to think about it is you can talk about things that are generally useful. I'm happy for you to teach each other how to loop through a two-dimensional array. In fact, the starter code has two ways. I mean, it's actually the same way twice, but it's done twice, the ability to loop through a two-dimensional array. So we're happy for you to talk about that, you know, in a generic sense. But when you start talking to people about exactly how to pick up how many mines there are in a certain square size space of a two-dimensional array, that's when you're crossing a line, right? That's when you're getting to the point where you're taking away someone's chance of learning how to solve that problem because you're giving them too much information. So that's the point where we would like to sort of draw the line. So totally fine for you to talk about all the concepts, but when it comes to applying those concepts specifically to the problems in Minesweeper, that's the bit where we'd like you to be working on it yourselves. because you're not really going to learn anything from it if you discuss it too much. You can discuss anything with us. So when you're discussing on the course forum and that kind of thing, you can ask us anything. We, of course, will moderate what answers we give you. If you say, "Dear Mark, what is the entire solution to this assignment?" I'm going to say, no. But I might help you with whatever problems you're having with getting the solution to the assignment. But I mean, like, within reason. Still give you a chance to actually learn from it. So we've got stuff about the submission here, but assessment scheme. So we have the assessment scheme here, and I've got some notes on it in those slides, but maybe we'll go through what's in the spec, because that's the exact correct thing that you're going to be marked on. So there are some things that would be issues. So if you submit someone else's work, or you work on something with someone else, there's going to be a significant penalty. This may often be the entirety of the marks for the assignment, if this happens. Sometimes it's less than the entirety of the marks of the assignment, but it depends on the situation. If you provide your work to someone else who submits it, then that's also a problem. I mean, this is like two sides of the same coin here. Definitely using someone's work who you did not who you basically stole from someone or paid someone else to do it, these things reach another level significantly, and there's a chance that we would actually fail you from the subject entirely for doing that kind of thing. So we really want you to get the chance to learn this yourself. So if you pay someone else to do it, A, you're out money, which sucks. B, you're out learning as well, which is going to suck in a couple of months when someone else says, obviously you can work with two-dimensional arrays, right? Because like that's one of the major things that was taught in 1511. So we expect you can work with arrays, and you're like, yeah, sure, I think I can work with arrays, right? So all you're going to end up with if you cheat on this early work is just the inability to do things later. So that kind of thing catches up with you. So just be careful. Another thing actually about that is what I find the majority of times that someone cheats on an assignment or something like that is usually at a point where you're lost, you're stuck, and you're desperate, and you feel like you're going to fail the course if you don't finish this. If you hit that situation, please talk to your tutor. So if you're in a position of desperation, you think that you just can't figure out how this is going to happen, and you're at the due date and everything's just going bad, and you can't figure out what you want to do, and you're not getting the marks you think you want to get for this course, please come talk to us. Go to a help session, or talk to your own tutor, or you can post on the forums if you want to. You can post, I think we can post private questions on the forums as well. Dean, can we post questions that aren't visible to other students? I'll wait for him to reply about that. But either way, there are ways to talk to us where you don't have to be embarrassed by it or anything. And I'm okay with you saying, I can't get it. It's not working. I'm desperate. I'm really at the point where I kind of want to cheat here. Yeah, Tom's saying we can post privately on the forums as well, so you can post there. So I'm okay if you say to me, look, I'm really on the verge of cheating here because I'm kind of lost. We will help you, right? So if it comes down to that, just let us know. We will find some time. So I will try to find some time potentially in the week 6 break, or if this is that desperate point, it might be just after the week 6 break, where you might be able to get you some one-on-one time with a tutor or something like that, just to get you over that hump. Like, we're not trying to punishingly fail people out of the very first assignment in computing here. And it might be a simple thing. It might just be that you need something explained in a slightly different way than I explained it in lectures, and maybe it'll just click. So if you reach a point where the problems are getting too much for you, please reach out to us, because I think that's the kind of thing that often leads people to cheating, and I would prefer that you reached out to us and we were able to help you than you cheated, because if you cheat, then you just don't even help yourself. Like, you'll get the marks now and then you'll kind of be screwed later because you didn't learn the content. So yeah, I mean, I always kind of want to, yeah, I could talk about that for hours and hours about what we can do and how we can learn the best we can. But I mean, I just want to leave it at that for the moment. So if you get desperate, come to us first, because we're getting paid to help you. So we'll help you. Yeah. Sorry, there was a link being held for review there that I just let go through. So it's yeah, there are help sessions. Actually, I've got a slide on that later. But if we, oh, I don't even have the class web page open. Wait, that's 19T3. Help sessions. There are now help sessions running every single day of the week. Let me zoom in here. Every single day of the week, they're in a lot of the same labs. Not all of them, but a lot of them are the same labs that you have your weekly labs in. And a lot of these people here are the same people that are teaching you, or people that are teaching other people, but people who are teaching 1511. They're all available. And while it's weeks 4, 5, 6, I think that's meant to be 4, 5, and 6, but 4, 5, and 6 here. There's enough of these that there should be time for everyone to come and talk to people at help sessions. I should I should point out that the later that you go to the help sessions, the busier they're going to be. So it's always better to start your assignment early and hit a point of frustration when you still have like a week before the deadline, and then you can get through that point of frustration, settle yourself again, and then start another section of work. If you hit your point of frustration on the weekend that it's due, it's a little bit harder to get help. So I would say try to get help before then. We have tutors standing by to help people. Alright, so, oh no, we were talking about the actual marks for assessment. Okay, so close to a pass. This is below a pass, but close to a pass. This will tell you, if you're at this point, that there's a bit of work that you need to do. There's maybe a bit of catch-up you need to do. This will be us saying that you've made a good attempt at stage 1, but you haven't really got any of the bits working. So maybe you've got some parts of the bits working, but nothing necessarily in particular. So I've got my close pass here as well. Maybe being able to place some mines, but not placing all of them correctly or something, and maybe but not necessarily dealing with the multiple commands, the sequence of commands at all. So that's what we would say is, like, we could still get you marks close enough that you're probably going to be okay in the course, but this would be like a warning to maybe go back and study some things before you hit the exam. The pass mark, to get a pass mark, we want this thing to run, right? So we want to be able to just compile your code and get it running. This is all going to be done on DCC on our computers. So I know a lot of people are working on your own computers and stuff. I want you to, if you're going to do that, regularly go back and forth and just log into VLab, pop your code in there, and make sure it's running on our systems as well. Because DCC is a slightly safer compiler than stuff like GCC and Clang and other compilers that you might use on your own computers. So DCC is going to really check that you're doing things the right way. And if you happen to be using other compilers doing things in a way that doesn't work entirely, like it might look like it works, but sometimes there's really insidious things underneath that some of the other compilers allow you to do that we're trying to teach you not to do to start with, because they're quite dangerous. If we get into those situations, you need to make sure that it's working on our system. So go back and forth and check on our systems. So passes, runs on our systems, scans input, able to make changes to the minefield, so it's able to place mines, and it's able to detect some mines either in a row or column, preferably both, because if you can do one, you should be able to do the other. But even if you can't do the other and you can do only one of them, you're still probably going to pass the assignment. The ability to detect and reject invalid input rather than just sort of crashing through it or something. Good style will give you higher grade passes. Also the ability to, if you can complete all of stage 1, that's going to push you pretty close to a credit. So a stage 1 is a credit, which is 65 or higher, is going to be all of stage 1 complete, and then anything up between 65 and 75 is going to be partial implementations of stage 2. So that means we're talking about placing the mines, being able to do the detection things, and then more marks above the credit is going to be getting into stage 2 and doing the things like the detect the square and the revealing, the actual sort of starting to play the game. I should also point out that we're talking about readability of code here as well. So it's not just whether it works or not that we're looking at, because especially at this early stage, we're looking at your code style and we're trying to get you writing code in a way that you can reuse it and other people can use it, because we're trying to train you not just to get code that completes a task, but gets code that completes a task now, and in 2 years' time it can be handed off to someone else and they can say, I understand this and I can modify this to do another task. So without you there to explain it, the code explains itself because of how readable it is. So 20% of the marks for this assignment are style marks. And if you look at the difference between, say, the HD and the credit stage 1, the HD here is stages 1, 2, and 3. The style marks are worth as much as the difference between a credit and an HD. So that's actually heaps. So that's something that's interesting. I'm going to talk about style marks in a second. But style marks are factored into these. So if you have all of stage 1 completed and it works really well, but it's not necessarily readable code, then you're not necessarily going to be able to get a credit for this. So I've got a slide on style. I'll talk about that in a second. The easy way to think about these jumps now at this point in the marking scheme is the credit, stage 1's complete. Distinction, stage 1 and 2 is complete. High distinction, which is 85% or higher, stages 1, 2, and 3 are complete. And then if you want to go all the way to 100%, stage 4 is complete, but there's also very, very readable code there. So if you have a perfect assignment that covers all of the tests that we could throw at it, you'll get 80%, and then we'll look at the assignment. We're going to mark it by hand, because obviously the only way to tell whether an assignment is readable to humans is to use human eyes. So your tutors are going to be looking at your assignments and saying, okay, how did they structure this? Did they move repeated code out into functions? Did they use good variable names so I can always understand what's happening? Are there comments that describe what is going on in a way that's useful? Other things, do we not have excessive loops within loops within loops, and ifs inside loops and whiles inside loops? The deeper we go into confusing people, the worse it is. Can we use functions to separate some of that stuff out and replace it with like English words and stuff like that? So all of those things are going to make your code easier to read and easier to use. For you to get full marks in style, I expect the code to be code that I could use to teach people with. And I'm not talking about the code example that I gave you that was like a huge mess. It's the code that I would use to say, okay, here's the best code that you could write, and this is the way that I want it to be. So if you can write code that is as easy to read as the stuff that I've been doing in lectures, or even better than that, because a lot of the time when I'm in lectures, I'm on the clock. You know, I've got like half an hour to do a demo for you, so I won't actually, like, the structure will usually be good, indenting will be perfect and stuff, but I may not have written full comments for things that I wanted to. Sometimes I'll have skipped over comments on a section and just talked to you about it while I was writing it. So that's the kind of thing that we'd expect. The other thing is, we're expecting, especially from anywhere credit and higher, for people to be making use of functions. So if you're not making use of functions and you're pushing into the distinction or high distinction, you're probably not going to get all of the possible marks that you could get there. Because not only is that going to be marked for style, whether you're using functions or not, but we're going to want to see you able to form some functions if you want to get higher than a credit distinction, high distinction. If you're just looking to pass, and you know you're just trying to get as much as you can, You can still pass without definitely using functions, but I mean, we snuck it in anyway. You're going to be using functions because we've made a few here. So at least, hopefully, you'll still be learning about functions, even if you're not yet at a point where you can write your own. But we would suggest you try writing one or two of your own, because they're not that hard to do. They'll earn you some marks in this assignment as well. Where were we? Right, so I've got some slides here. I might make these slides available, actually. I'll just put them in the lectures section, or maybe in the live streaming section. So yeah, that's some stuff here that we don't really need to talk about, because I think I've talked about that on the other, while I was looking at the assignment spec as well. So I think everything here, yeah, stage 1 complete, stage 2 reasonably readable as a credit, shows some use of functions. So how do you get free marks? This is where you get, well, not entirely free, but this is like probably one of the best places to score marks in this assignment. As I was saying, the style marks are worth nearly as much as the difference between a credit and a high distinction. And so a lot of people consider credit students and high distinction students, people with average marks at different levels, to be a very different caliber of student. And what I'm saying is that massive difference in the caliber of student, in my mind, is often not how good their code is, but how useful it is to people. So I don't consider code to be useful to people if I can't read it. Then it'll run once, but I'll never be able to change it, I'll never be able to modify it, and I'll never be able to understand it. So it's very important that we think about how well our code goes down for humans, not just how it goes down for computers. So, style guide. If you follow the style guide, and you can use 1511 style on your assignment in the same way that you've been using 1511 style on a lot of your labs and things like that, you can get some advice from the 1511 style program, and it'll catch the little things: indentation, spacing, use of white space between operators. It'll catch those things pretty easily. It will try to give you some advice on variable names and things like that, but it's never as smart as a person there. So you really want to think about that yourself. And if you want to, you can even talk to your tutor and say, okay, here's a section of my code. Most of my code looks a lot like this. What do you think about style here? And your tutor will be able to give you a little bit of feedback. I mean, one of the biggest and most important things in feedback for this assignment is going to be style feedback from your tutors. So when your tutors actually mark your assignments, they're going to say, these are the things that I found readable or not readable in this assignment. So that's going to be one of the things that's most useful. In terms of functionality feedback, it's nearly like you know that yourself. You've been making it, you know which tests you were able to pass and which things you were able to understand. But in terms of readability, we really like to have some human feedback on that. So little things you can do for certain. Yes, correct indentation, consistent bracketing, so the brackets are lined up vertically correctly. Variable names that are understandable to a human, comments explaining your intentions. You can also use those kinds of comments that I've been doing, which help us track the state inside while loops. So the idea of, like, at this point in the while loop, every time I reach this point, I know how many things I've done. Those are pretty handy. They help you remember how you're tracking through the while loop. Structuring your code, so the idea of paragraphing, the idea of having white space between things, so that you can sort of bundle things into packages of what they do. Quick hint: if you are paragraphing your code and bundling them into sections that do one thing, it's very, very likely that that one paragraph might be a really good function. Especially if you notice that paragraph and another one later being identical or really, really similar, chances are that's one function that could be called twice. You'll see how it goes. Yeah, and using functions themselves, so that not only do they separate out some code that could be repeated, they might separate out some code that could be too complex to read. So if you do have a while loop inside a while loop and an if statement inside a while loop that runs another while loop, really hard to read. So if some of that functionality is pulled out into its own function, and so it has a nice name there, that's hiding the fact that it's another double while loop. That will lower your indentation, which will reduce the human confusion in things, and it will also make things more readable because it just shortens the code that people are looking through. Another thing is to make sure your functions are always commented themselves. So what we do when we put our functions at the bottom of the file, we'll put a comment for each function just going, okay, this thing does this. It's the same way that when we have our whole program at the top, we've always got a comment saying, okay, this program does this. We want each of our functions usually to have at least a one-liner saying, okay, this is what this thing is for, and what kind of inputs and outputs it has. So a lot of that stuff is going to get you free marks. That's going to get you something really easily. Okay, moving on. Oh wait, we have... okay, so Sascat is asking, when my line of code gets too long, how do I bring it down to a new line and indent it to the proper indentation? And yes, is asterisk ampersand, that's... Who was that? Was that Donna? That's one of the tutors, isn't it? It is, yep. Cool. Let's see if you have an example of it. But I mean, I've definitely shown you one example of when the printf gets too long. So sometimes when the printf is super long, you end up with like this massive line because you've got all of these variables going off the end of the line. So one way we could do that was actually set up the normal brackets of the printf in the same way you would like a while loop or an if statement. So it opens and then it closes below where the printf started, and then you can put your lines indented inside that, and it just looks like another code block that's inside a set of curly brackets, but this time it's just inside the brackets of a printf. If there's other things pushing your lines too long, you might want to think about putting stuff into functions. So sometimes the reason why your line is too long is because it's been indented really far before it started. Another reason why things might be too long is if you're checking multiple things in an if statement. So you're saying, or a while loop, where you're like, if this, or this, and this, or this, and this, then it ends up really long. Those things also can be put down onto separate lines if you want to. So you can do the same thing with the brackets, and you can open and close the brackets in the same way that you would the curly brackets with them kind of vertically aligned. And then you can indent in and go, okay, if this, or if this, and this. And then you can do it vertically if you want to, and you can read down. Yeah, I'm trying to think of other situations where it might be too long. I think a lot of the time, when we're going too far across the screen and making it hard for us to read things, separating things into functions is nearly always that. Yeah, right. So Michael's got an example there of a long function name and a long list of arguments. So we do want to think a bit about the length of the text that we put in things. So I probably wouldn't go much longer than this as a function name, print debug minefield. I mean, it makes a lot of sense, but let's say, for example, I'm just going to butcher this code. So let's say I don't know what's going on here, but if I had another minefield. So I've got and then I've got int score double time. If I'm just adding things in here just for a style example. This isn't anything functional. Let's just go there. So we've got this massive thing like this, and let's say print debug minefield multiple. I would probably never write this because it's really long, but I'm just using an example. So if we're getting to this point, and this is very not readable at the moment, because when we think about when we're scanning code, our eyes are going to look at about this much of it, and then they're going to go down to the next line, and the next line, and the next line, and that's fine if this doesn't go much past here. But once it goes past here, we're definitely missing this. We're going to really, really easily forget that there was a score and a time variables in there. So one thing that we can do with this, and this is something that we can do anytime we have brackets, so curly brackets or normal brackets are things that we can use to contain bits of code. So what I've just done there is I've just moved the brackets down to their own line. And then I can tab indent this and say this is a set of brackets that's attached to this line here, and here are some bits and pieces, and if I want to, I can put these on separate lines to make it just a little bit easier to read. So I could do this and go, okay, they're like that. If I want to be really kind of specific about it, I could do it like this. This could be getting really long in the vertical sense as well. So you can choose how you want to do this. I mean, this is like super clear. It's taking up a bit of space, but it's super clear. So you can do this if you want to. So that was just in this sort of definition of the variable. I sort of butchered this. But if we were going to use this variable, so let's say up here we have print debug minefield multiple again, and then we've got minefield. I'm just going to use some stupidly large variable names just to see, just to show you what we do when this thing gets really long. I probably would not make variables quite this big. I mean, you can. The readability of the individual variable name versus readability of like the whole length of the line, that's always a bit of a trade-off, right? So I would actually nearly say this is a little bit too long. I have like excessively explained what this variable is. I'm pretty sure I could have explained what it was and distinguished it from all the other variables with less letters here and gotten away with it. So what do we have? We had time as well. So okay, current elapsed time. Okay, so I'm being long-winded on purpose to show you, like, if this goes over, what are we going to do? And again, if it's like this, I can do the bracketing thing. So I'm going to take the brackets there. Oops, I press caps lock instead of tab. I can indent here, and then I can separate these variables onto their own lines if I want to. And then I have something that's not going to go overboard, and if someone scans this, they're still at least going to see all the variable names. So that's one way I would do that. Another way, if this was inside something else that was indented and stuff, and it was just really far along, anytime I've indented more than 3 times, I start thinking about it. So here we have indenting once, indenting twice, indenting 3 times. If I start indenting in here, if something, oops, if this, now this is indented very far, I start to think that maybe people might be losing track of things here. So this is the kind of thing where I might go, yeah, matches certain criteria, because this is an if statement. I mean, this, if it was an actual if statement, it would say what criteria it matches, so I would at least try to explain stuff when I get this deep. But I would also start to look at how I can push this into another function. It's okay to call a function from inside a function as well. So maybe this section here that's doing stuff could be in another function, so I go while loop through things twice, and then pass in one element of the minefield as a pointer to another function, and that function then works on that part of the minefield, right? So we could definitely do that instead. Yeah. The 1511 style, I don't know if it will tell you at this level or the next level. So it might tell you you're too far indented after 5 or 4 indents, I'm not sure. But usually when it gets to 4, that's when, for me, little red flag goes up in my head, and I'm just like, okay, I need to think about whether this is going to break someone's brain or not. And it's really hard to tell, because you always think that your code's not going to break your own brain, but you're deep in it. and you understand it, you wrote it. It's much easier to break other people's brains, even like if you consider other people who are going to look at to be smarter than you. So you consider your tutor knows more about programming than you. So you think your tutor, not everyone knows more about programming than everyone else, but whatever. If you think your tutor knows more about it than you, and you think, nah, they'll be fine with this even though it confuses me, chances are it's the other way around. If you wrote it, there's much less chance you're going to be confused by it than someone who's trying to read it without having the chance to really delve into it. So anything even a tiny bit confusing, think about shrinking it back down. So the fourth indent is a dangerous place, and there's going to be other ways around it. Okay, I hope that was enough information for both of you who are asking about trying to shorten lines. Nearly always it's a matter of going, at some point there's some brackets here, and I can use the brackets to just contain a section and then drop it down to other lines. But even if we're talking about, say, you know, weird complex mathematical functions, so it's like this value plus that value, I'm just making up random things here, divided by, put spaces between things, extra values, 5 plus something else, I don't know, big number. Maybe I had a define called big number. And I wanted to shorten this. I mean, this one isn't even that long, but I wanted to shorten this. You can actually just split things onto multiple lines. You've just got to be careful because it's easy to confuse people once you split things on multiple lines. So sometimes if I'm going to split something, sometimes I'll tab it in, because usually anything that's at this level of indentation, we consider it to be a new line that's starting a new instruction. So if I've got other stuff, I might tab it in. It's always a bit difficult to really be sure about how to split the lines, but some of these techniques will hopefully help you. I just realized I pressed Control C on Minesweeper. I've absolutely butchered this file. I'm not going to use this for anything else anyway, so that's okay. Cooper has said, is it possible to write an entire C program on one line? Yes, it is. Please don't do it, but yes, it is. So, your C compiler actually treats all of the white space in your code as the same thing. It just treats all the white space in the code as stuff it doesn't read. So it just goes, I don't read white space, don't care, I'm looking for symbols. I'm looking for code symbols that mean something, and I'm piecing them all together. So, okay, let's... This... Okay, where is that going? That's going out there. That's legal C. Your compiler is going to be able to read that because it's just looking for like keywords like that, special things like semicolons, and after the semicolon it goes, okay, there's some amount of white space, could be 0 or more amount of spaces or enters or anything, and it'll just look for the next thing up until the semicolon. And it'll look for the structure being correct with the brackets and everything, but it will still do this. But please don't do this. I appreciate the thought experiment. But yes, if you wanted to, everything can be on one line, and then when you get an error, it's like, error on line 38. Oh, thanks, that's really useful. It's error in one of these 8 instructions that I put on the same line. So it's very, very bad for humans, but hilarious. I guess if you really, really like your lab partner, you could go in and complete one of the lab solutions, and then just send it across to them and go, oh, can you code review this? And the whole thing's on one line. Hopefully you've got a copy of it somewhere else that isn't on one line, so you two can actually work on it. But I mean, could be funny. Please don't do this. Whoever's working with Cooper, I apologize that I may have allowed this idea to get into their head. Okay, so back here to other things. Okay, so there's one little extension thing on the assignment, which is the Hall of Fame. So you may have seen the Hall of Fame section in the assignment spec. The Hall of Fame is not necessary. At no point is it necessary to do. You do not earn marks for it. As I said here, It's worth bonus marks, but not actual marks. So you're not going to earn any marks for this. But if you're interested and you want to explore further, we have interesting ways you can explore. So this is like the challenges in the labs. They're not necessary to pass the course. Some of them are not even part of the course material. I think all of these, yeah, all of these are not. Oh, actually, this one is kind of part of the course material. We just haven't taught it yet. Um, but most of these are things we're not even going to teach in 1511. But they're things that we think might be interesting that you could flow on from a finished Minesweeper assignment. And I should say, please don't go off and do Hall of Fame stuff if you haven't finished the assignment, because you kind of want to finish the assignment, get marks, and then go off and explore other things. I mean, I do love it when people go off to explore things, because I think that's how we develop a love of programming, is by sort of, I guess, taking off those training wheels and going off and saying, okay, what could I do? Code has this kind of limitless potential of all these things we could make out of it. And once I have a start, I could just branch off in all these different directions. And so this is what the Hall of Fame is. I should also point out here, any other cool ideas you have, you can do them as well. So we have an email address for the Hall of Fame. You can send us some stuff for the Hall of Fame there, and we can look at it. Especially because if you make some of these changes to your actual assignment, it'll start failing tests. So submit the assignment that works, and then do your Hall of Fame stuff if you want to, and then send it to us. It's interesting. Some of this stuff is kind of cool. I think one of the ones that's quite interesting is the reveal function that acts like the real Minesweeper game. So that's one of the things that we weren't able to put in the game itself for the assignment, because it involved a process, a way of programming that we're not necessarily teaching 1511, that you're going to see later in some other programming courses instead. But if you happen to have learned recursion from some other source, or you want to go look it up and learn it, there's interesting things. You could do something like this to create the reveal function that sort of just grows outwards and only stops when it hits mines. It doesn't grow out in the radial directions that we had with the 8-pointed star, but just grows in every possible direction. So there's things like that. The randomizing starting locations is cool as well. But any ideas you have that you might want to use the Minesweeper setup that we have to build, those could be cool. I want to see someone build an entire Sudoku game out of this. That's going to be as big as the entire assignment again, so just be careful. You may have work to do for other courses, and it might be worth doing those. Okay, so we're pretty much out of time. So I was going to go look at the pointer demo that we didn't finish, but I don't really have time to do that. So I did want to talk about issues with coronavirus at the moment. I'm going to talk about this more, and I'm going to send some notices out and everything, but I did want to at least tell people that UNSW is not necessarily like... UNSW knows what's going on, right? They've been talking to the government about this, and we're trying to figure out what we're going to do. So with the lectures that are coming up, I mean, we have been given health warnings for any gatherings of people of 500 people or more, and the lecture theatre is 500 people. So if you're not comfortable in coming to lectures, I have no problem with you staying home and just watching the lecture videos instead. I mean, like, if you needed to do that for any other reason than the fact that there's a virus going around, I was happy for you to do that anyway, because sometimes when we consider accessibility issues and stuff like that, it's totally fine for people to stay home and watch recordings. At the moment, back and forth talking with UNSW, I know that there's a lot of companies out there and stuff like that that are talking about shutting down and stuff. UNSW is assessing the health risk at the moment, and it's not considering a serious health risk right now. But it might change in the next couple of weeks. So we are aware and we're monitoring it. But at the moment, UNSW's recommendation to us is that for the moment, it's okay for us to continue teaching as we're teaching. So it is an option if you need it. So if something happens, or you've come into contact with people who have been affected by coronavirus and you want to self-isolate and work with the lectures at home, you can totally do that. We are going to continue with the face-to-face teaching with the tutorials and labs, but if we do need to, because there is a possibility, like I don't know the plans that university has, but I think that based on what other companies are doing, there is a possibility that university may close campus itself and push everything remote. And so you'll see a lot more of me via the camera instead of face-to-face. If that does happen, we will let you know, and we will put measures in place to make sure that you're still getting the teaching that you should be getting through all of this. So for the moment, it's actually business as usual. We'll still be fine for the moment, but you also definitely have the option, if you need to not go to the lectures because they are recorded. And if you have any issues and you want to clarify anything with us, you can email the CS1511 email or ask on the forums and stuff like that. And as the situation develops, we'll just keep giving you information about this. Because I think it's a very kind of tumultuous time at the moment. There's a lot of potential issues going around worldwide, and so we need to make sure that you can still learn about programming without being at risk of getting a life-threatening disease or passing on a life-threatening disease to your family members or anything like that, you know. So that's the last thing that we want to happen, is for anyone to actually be in danger while they're trying to learn. So if we do have to suspend face-to-face teaching at some point and switch to remote, we will keep you up to date on everything and what's happening, and we'll make sure that we can, as much as we can, like I can't guarantee we can maintain the same quality of teaching, but as much as we can, we'll try to. Yeah. Okay. Epic note to have to end that live stream on, but we've got our 2 hours here, and so I apologize we didn't get to finish this pointer swap code, but maybe I will get some time sometime in the next couple of days to finish that example that I started in the lectures. But I thought that at least touching base on the issues that might be happening with coronavirus in the near future, that I should at least tell people that we're thinking about it, and we'll let you know if anything changes. I'll put these slides up, maybe just in the lecture section for this week. And thank you everyone for dropping by, and I hope this was useful. And obviously this is going to go up. It's just going to be up as a video as well, so you can go back and watch it again if you want to go back over anything I said about the assignment. Any further questions on the assignment, please hit up the forums, because any question you have of something that I've missed talking about here, chances are someone else needs that information as well. So that's why we love the questions to go on the forums, because we love being able to help lots and lots of people with your questions. Alrighty, that's it for me for today. Thank you very much all. I will see some of you, I guess, on Tuesday in the lectures. And yeah, good luck with Minesweeper. See ya.